This video is to help you guys through Lab 13. In our previous labs, we learned about methods. A method is code that can be called. It performs an action. We can use that code over and over again in our program or in other programs without having to recreate all of this code. A class is a bunch of methods combined into one that control an object. So we're getting into object-oriented programming at this point. We're going to start off with a simple object like a box because it's something that we can all visualize very easily. But I want you to think about some of your games that you play as well. In Angry Birds, each character is its own class. So you have a red bird and you have a green pig. A red bird has certain characteristics like its color, its size, its capabilities, as compared to a green pig. It's a different size, it's a different color, and it performs different actions. So each of those objects is going to be its own class. If we think about a person is an object, and a person has different characteristics. We all have different heights, different weights, different hair colors, different eye colors, all of those things. And then we are all capable of doing different things. Some of us can dance, some of us can play sports. So our characteristics, what we look like, are the data members or the variables, and then the different things we can do like sing or dance or play sports are the methods or the actions we can perform. So Lab 13, we have a sample here of a box class. Now a box has characteristics like a height, a width, and a depth. We're going to keep this very simple to begin with. This is a UML class diagram. It has 3 parts. The top part here is the name of our class, so this is a box class. The second section has all of the data members. These are your variables. Data members are private. We don't want anyone to have access to them, only if we grant them permission. So we put a minus in front of them to indicate that they're private. Then we put the name of the variable, a colon, and the data type we're going to use. So for this simple box, we're saying that they have to be ints. So either they're all an even number of inches, or we're breaking it down to centimeters or something along those lines. They could be doubles if we wanted it to be 1.5 inches. Then the third section is our member methods. These are all of the actions that take place within our class. These are public, so we indicate that they're public using a plus symbol. And there are some methods that are kind of required for a class. First being, every time we have a data member, we have to have a getter and a setter for that data member. So I have a height data member. That means I have get height and I have set height. Now a getter is one where the user can say, get me the height of the box, and it will look in the program, see how high the box is, and send that information back. So there's no parameters. This is our parameters, but it returns an int because the height is an int. Then I have a setter. A setter is for when I'm first creating this box and I want to know how tall is this box that I'm adding to my inventory. So this is where the user tells us the height, or the user tells us the width. So we do have parameters. They're going to send me an int, but I'm not sending anything back. I am just changing the value of my data member. That's the job of a setter. So a getter tells the user what the value is. A setter takes the value from the user and changes the data member within the class. Then you're going to have the actions or capabilities of your box or your class. So this one, we are going to have a method in there that will calculate the volume of a box. And so it's called calc volume. So if I have my box all here and I want to know the volume, I don't have any parameters because I already told it the height, the width, and the depth when I called the setters. So now I just want it to perform the calculation given the information that's stored in the data members, and it will return to me an int, or maybe it's a double, depending on our data types that are there. Okay, so again, this is a simple representation of a box. Now for ours, if we scroll down a little further, we're going to create a token machine class. And what we want this to be like, think about when you go like to Chuck E. Cheese. You have a token machine. So if I put in a dollar bill, it sends back 4 Chuck E. Cheese tokens. If I put in a $10 bill, it sends me back 40 Chuck E. Cheese tokens, or something along those lines. Now we're going to create one that's a little more simple. We're going to create one that only takes quarters, and it returns tokens. So if I put in 1 quarter, it returns 1 token. And that's all we're going to worry about doing, because we're going to start out really simply. Now, I like to use Microsoft Word to create my token class, and so I'm going to show you how to do that. I'm going to move this out of the way and then open up Microsoft Word and just choose a blank document. And the best way to create a UML diagram that looks really good is to create a table. So I'm going to go to Insert, Table, and I only want 1 column and 3 rows. Those 3 rows represent the 3 parts to our UML diagram. Alright, I'm going to click inside the first part, and I'm going to center, and this is where I am going to put the name of my class. Now I want a little bit of space above this. Now if I try to press enter, it's going to bump my table down, but if I hit my space bar and then press enter, it thinks I'm inside the table. Anyway, I just want a blank row above and or blank line above and a blank line below, just to kind of give it a little bit of a padding around the outside. Okay, first thing we need to come up with is a name for our token machine. And guess what? We can be really basic and just say that my object is called a token machine. You can name it whatever you want, just make sure it's somewhat meaningful, that we understand what the job of it is. So, you know, it could be so if you can come up with a better name for it than token machine, you're welcome to, as long as I can still identify what the purpose of the class is. Okay, now I'm going to come down into my second section. I'm going to put in a couple returns just to give it a buffer above and below. And then I also want to put a little margin on the side. So I'm going to come up here to my increase indent button, and I'm going to bump that over just a little bit. Okay, so now I need to think about what are my variables in my token machine. So we think about this. What does my machine do? I put in a quarter, and it sends back a token. So I know that I need to keep track of quarters and tokens. So those can be my 2 that I start with. These are private, so I put in a minus to indicate private. Then we put in the name. So let's start with quarter, or quarters. We'll say quarters. And then I put in a colon and a space. And what is the data type? Can I have a half a quarter? No, so I'm going to have it be an int. Then I'm going to press enter. My next one, I know that I need to keep track of tokens. So I'm going to create a tokens variable. And then I put a colon and a space. And again, I can't have a half a token, so I'm going to use ints for this. Now, if I were creating a more complex token machine that took dollar bills, $20 bills, pennies, nickels, dimes, quarters, half dollars, gold dollars, silver dollars, I would have to create a variable for each of those. So to keep things simple, we're just going to say all we're taking is quarters and all we're sending out are tokens. We just want to keep it simple. So we should be good there with our variables. Now I'm going to come in here, press enter a couple times to give a buffer, and indent it. Now we're ready to think about the methods that we have. Now to begin with, we have to have something called a constructor. The job of the constructor is to just set up the class, like initialize the variables and set the beginning values for our variables. Most of the time those are just going to be set to 0, but sometimes we have some values that we want to start out with a certain number. So, let's say that I get a brand new token machine and it comes preloaded with 5,000 tokens. So I might want my constructor to start out with 5,000 as the token count and 0 for the quarters. When you think of a vending machine doesn't start out empty. It starts out with, a whole row of each type of soda to begin with, so a beginning inventory. For this one, we'll keep it simple again. We're just going to create a basic constructor that sets everything to 0. And to do that, we put in a plus symbol, and your constructor is going to have the same name as your class. So this is going to be called token machine. And it is not going to have any parameters, so I'm going to keep that blank. And it is not going to have any returns, so I'm going to keep that blank. All its job is going to be is to set the initial values of everything. So when we get to writing the code, all it would look like is you're declaring of your variables and initializing your variables if this were a regular program. So I would say int quarters equals 0, int tokens equals 5,000, or whatever. Okay, so that's our constructor, and every class has to have a constructor. Next, we need to have our getters and our setters for each of our variables or each of our data members. So I'm going to have one called get quarters. Now a getter does not have any parameters because the user's just asking you, tell me how many quarters are in the machine right now. Tell me how many tokens are in the machine right now. But it's going to return a value. And in this case, again, I can only have a whole quarter and a whole token, so I'm going to use an int. Then I also need one for my tokens. So get tokens, no parameters, and this will return an int. Next, every single one of our data members has to have a setter. So I'm going to have a public set quarters. Now this is where the user can send in a value to tell how many quarters are there. And so this one we're going to have an int where the user sends in a number of quarters, and it is not going to return anything because the information is coming from the user to the machine. On the getter, the information is coming from the machine to the user. So that's why they're complete opposites. We also need one for set tokens. And it's going to have a parameter of an integer and return nothing. So those are the three things that are required of every class: a constructor, getters, and setters. Now we have to think about, what does this machine do? What are all of the possible actions? We're keeping this one really simple. So all I can do is add a quarter, which then in turn sends me back a token. And we have to think about how we want to program this. I could have one method that's called add quarter, and in that method, anytime I add a quarter, it automatically sends back a token. Or I could have that broken into two, where I add a quarter and remove a token. So you need to talk to your client and see how they would like it to work, or you need to think about what you would think is most efficient. To give us a little more practice, we're going to create this as two separate methods. So I'm going to create a public method, and I'm going to call this add quarter. Now, can my machine take more than one quarter at a time, or can I only put in one quarter and it returns one token? Based on the instructions on this, I mean, it sounds like if I put in one quarter, it's automatically going to return something else. So I really don't need to worry about telling it how many quarters I'm adding. And so I'm going to say that this does not need any parameters, because anytime I say add quarter, all it's going to do is something like quarters plus plus or quarters plus 1. It's just going to add 1 quarter to the machine. So there's no reason for any parameters to come in. And then does this send any information back to the user? No, it doesn't. If I, the user, want to know how many quarters I have right now, I have to call get quarters. I can't have this add quarter do both. It's really just bad form to do both in one. Okay, so I add in a quarter, and then it sends me a token. So I might have one here that's called remove token. Now, does the user have to send me a number, like how many tokens to remove? Not on this one, because I'm putting in 1 quarter and it's giving back 1 token. If I were creating a more complex one where I could take in 5 tokens or 5 quarters, then I would need to know that, hey, I'm removing 5 tokens, and then I would want to send in the number 5. But to keep this simple, we're going to say, you know what? They put in 1 quarter, it automatically sends back 1 token. So I don't need any parameters, because the code that goes inside of this is just going to be tokens minus minus, which decrements tokens by 1, or I would do tokens minus 1. So this is going to have a void return. Very simple. Now, is there anything else our token machine can do? Can I cache in tokens and convert them back into quarters? Maybe our machine could do that. So what kind of method might I want, and what would happen with that method if I wanted to do it that way? So for a few bonus points for you, if you could come up with a way to cache in tokens, unused tokens, and get reimbursed quarters, that would be great. You might need one more method, or you might need a couple more methods. You have to think about how you'd want that to happen. Not a requirement. Just something, if you do that, I'll give you like 5 bonus points. So like, what does that amount to? A 20% extra credit. Okay, now before we turn this in, we want to spruce it up a little bit. I'm going to shrink down the size of my table here, just so it looks a little bit more like the one in there. Now, if you're doing the extra credit, make sure you finish that, pause this tutorial, finish adding stuff, and then get back in to do the submission. I also want to put my name on this, so I'm going to come up and double click in the header, and I'm going to key in my name and press enter, put in my class period, and I want to know what project this is, and this is Lab13. And then I can close my header. Then I'm going to go ahead and save. And you want to go to your F drive and put this in your computer programming folder. And let's just name it Lab13. Then, in order to submit this, I'm requesting that you submit a PDF. So we're going to convert this by going to File, Export, Create Adobe PDF. And again, keep the name as Lab13 and save. And then it will convert it to a PDF. When your PDF comes up, you can go ahead and close it, and then you can close Word as well, and you're ready to upload this into Canvas for credit. Now, when we get into the next lab, we're going to take this a little bit further. We're going to create a class that does a lot more than this, and then we're actually going to be creating the code that goes along with that.